Hello students, in this lecture video I will demonstrate how to create scatter chart using Excel 2013. So here we have been given the data set. We have data on bottled water sales in cases, and we have data on high temperature of the day. So this data is coming from some amusement park during the summertime for, let's say, 15 days, and the managers at the amusement park would like to know whether there is any relationship between the temperature of the day and the number of cases they are selling, because logically it makes sense. If the temperature goes up in the day, you tend to sell more, but we need to prove this statistically. So to plot the scatter chart, you simply select the data, go to insert, drop down this scatter and select the scatter chart here. So this will put the scatter chart here. Now scatter chart shows the linear association between two variables. So if there is any non-linear relationship, this measurement will not work. So it only works for the linear relationship, and we do see the linear relationship here. Looks like a linear means a straight line. Looks like when the temperature goes up, you tend to sell more bottled water cases. So the strength of the relationship can be measured by using covariance and correlation. But before I go there, let's format this chart here. I would like to put some access titles here. I would say this is high temperature of the day in degrees Fahrenheit. This is bottled water sales in cases. So this is my plot here. You can also do a lot of interesting thing here. Since we are trying to find the linear relationship, I can show a trend line there. So if you click on this one, it shows roughly a linear relationship between the temperature and the number of cases you are selling. So this is called the best fit line, also sometimes known as the regression line. So let's find out the covariance, the strength of the relationship. So that's gonna be covariance, and we're gonna use the formula here, equals covariance for the sample. So it returns sample covariance, the average of the products of deviations for each data point pair in two data sets. So I'm going to select this one, say array 1, comma array 2, close parenthesis, hit enter, and that gives me a positive value. So if the value is positive, greater than 0, that means there is a positive linear relationship, which means if one goes up, the other one also tends to go up. If the covariance is 0, that means there is no linear relationship between the two variables. And if the covariance is negative, it means there is a negative linear relationship, which means if the temperature goes up, you will see decrease in sales. So that's how you measure the covariance. But the problem with the covariance is it shows you the product of the units. So which means, if you measure the temperature instead of in degree Fahrenheit but in degree Celsius, this will change. But you're not changing anything, you're just flipping the units. So covariance often is very confusing to interpret because it's putting values in terms of product of units. So what we do is there is a better one that shows the relationship, and that's called correlation. So let's find the correlation between the two variables. Correlation returns the correlation coefficient between two data sets. Array 1 here, array 2 here. So that shows the the correlation value. Now this coefficient is 0.93. The closer it is to 1, the more strong the relationship between the two variables. So since it's pretty close to 1, there is a strong relationship, or rather linear relationship between the two variables. If the correlation is 0, that means there is no relationship. And if the correlation is nearing -1, that means there exists a strong negative linear relationship. So in this case, it's very easy to interpret, because it's just the ratio. It's not showing value in terms of product of units as does the covariance. So correlation is often very easy to interpret. So since 0.93 is pretty close to 1 and it is positive, we can conclude that there is a strong positive linear association between the high temperature of the day and the bottled waters cases we are selling. So I'm gonna say since. So with this, I conclude my lecture video here. Thank you very much for listening.